Welcome viewers, in this video we will see the details about Reciprocity Theorem. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. The Reciprocity Theorem, one of the theorem available in circuit theory. First we will see the statement. In a linear bilateral network, a voltage source V in a branch gives rise to a current in another branch. The voltage source available in one branch that will give the rise of current in another branch. If V is applied in the second branch, the current in the first branch will be I. Suppose if we interchange the voltage from first branch to another branch, the current in another branch will be reflected in the first branch. That is the statement given by the reciprocity theorem. This V by I is called a transfer impedance or resistance. Right, now we'll see the diagram so that you're able to understand clearly. So this is the linear bilateral network is available. So the current, the voltage source available in the first branch. So there is a rise of current in the second branch, that is load end. This is the source end, load end. The reciprocity theorem, the statement is, if you transfer this voltage source from the source end to load end, that is that side, from this side to that side, the current in this side is reflected in the first branch. Right? That is a statement given in the reciprocity theorem. So this is the linear bilateral network. Voltage source available in the first branch, current is rise in the second branch. In this reciprocity theorem, if you interchange the voltage source from first branch to second branch, the current in the first branch will be reflected in second branch. So that is the thing. So this V by I is called a transfer impedance or the resistance. On changing the voltage source from branch 1 to branch 2, the current I in the branch 2 will appear in branch 1. So there is a statement, right? While interchanging the voltage, the current in that branch will be reflected in the first branch. Now we'll see the one solved problem. So in this solved problem, based on the reciprocity theorem, contain the DC circuit, the DC elements. For the circuit shown below, find I3 and verify the reciprocity theorem. So the circuit is given. In this circuit, we need to find the I3 current. So that we can treat that this is a load end. The source is available in the I1, available in the branch 1. Right? We can take this is a branch 3. This is branch 2. So our the problem given is we need to find the I3 value, current I3 value, and also we need to verify reciprocity theorem. So this is the first branch contain voltage source, second branch, this is the third branch current we need to find. So first we need to proceed with this circuit. We need to find what is the value of I3. In order to verify the reciprocity theorem, the voltage source available in the first branch should be transferred to the third branch. The current, so that the current in the third branch will reflect in the first branch. So that is the reciprocity theorem. So first we will take the circuit as it is, we will find I3 value. In the second step, we will transfer the voltage source from the branch 1 into branch 3, and we need to verify the current in the branch 3 will be reflected in branch 1. Right? So we will go to the step 1. We will proceed as it is in the circuit diagram. Say this is the loop 1, loop 2, loop 3. We are going to apply the KVL, Kirchhoff's voltage law, loop method by equation, by equation method. What is this equation? This is voltage matrix, current matrix. This is resistance matrix. V equal to I into R. Right? Voltage matrix, current matrix, and resistance matrix. What is this first one? This is R11. R11 means the resistance available in the loop 1. The sum of resistance available in the loop 1. Right? So 1 plus 10 plus 3. These three resistors are available in loop 1. So 1 plus 10 plus 3. So that is 14. What is this R12? The resistance available between loop 1 and loop 2. Commonly available between loop 1 and loop 2. So loop 1 and loop 2, the 10 ohm is available. Is commonly connected available between loop 1 and loop 2. So that is 10. What is this R13? The commonly resistor available between first loop and third loop. So this 3 ohm is connected between loop 1 and loop 2, this minus 3, right? Based on the current direction, it is given plus 10 or minus 10, right? If the both the currents are flowing in the same direction, then it is minus. Opposite direction means 10. See this current is flowing this direction, this also flowing in this direction, same direction, so plus 10. See here, this current is flowing downward, this current is flowing upward, so that minus 3, right? Same direction in positive, minus opposite direction means negative, right? So this is nothing but R21. 21 means the resistor commonly available between second and first loop, that is same thing, 10. This is R12, this is R21, so 10 ohm. What is this? Is R22, the total resistance available in the second loop. What are the resistors available? This 10 ohm, 2 ohm and 2 ohm. So 10 plus 2 plus 2, right? R22 is nothing but total resistance available in the second loop. What is this? This is R23, right? Available between second loop and third loop. So this is second loop and this is third loop. So this 2 ohm is connected commonly between second loop and third loop. That's 2. See the current direction, this is going upward. This is also going upward. So plus 2, right? So this is anti-clockwise direction, going upward direction. This is all clockwise direction, also upward direction, right? This is R31, the commonly resistor available between third loop and first loop, that is minus 3. So very similar to this. This is R13, this is R31. Then this is R32, third loop and second loop. This is 2 ohm, very similar to this. This is R32, this is R23. And the final one, this is R33, the resistance available in the third loop. This is the third loop. What are the resistors available? 2 ohm, 3.7 ohm and this 3 ohm. So total resistor available between third loop is this one, right? So this is R11, total resistor in loop 1. R22, total resistor in second loop. R33, total resistor in third loop. This is R12, the common resistor available between first loop and second loop. Similarly, R13, between 1 and 3. Then R21, R23, this is R31, this is R32, commonly available between third and second loop. The current is I1, I2, I3. The voltage available in the first loop is 10 ohm. See the current direction, current is going from bottom to top, that is negative to positive, so that plus 10, rise in potential, right? So the current is going from top to bottom, that is 10 ohm, from negative terminal to positive terminal, so that plus 10, right? So in the second and third loop, there is no voltage source is available, that is 0, right? So after adding this, 1 plus 10 plus 3 is 14. Then 10 minus 3, 10. This is 14. This is 2. Minus 3, 2. By adding these 3, we'll get 6.375. So there is a small correction is this. This is the 1.75. This is not 3.75. This is 1.375. So that 1.75 plus 2 is 3.75 plus 3, 6.375. Right? So this is 1.75 ohm, not 3.75 ohm. So this value is correct, 6.375 by adding this. Now we got this value. This matrix is framed. R matrix, I matrix and the voltage matrix. Our aim is to find the I3 value. So that we will find a del value and del 3. So that I3 equal to del divided by del 3. So this is nothing but delta value. This is the delta value. So by replacing the third column with the voltage matrix will give delta 3. Right? If we replace first column delta 1, second column delta 2, third column delta 3. We need only I3, so we will find only delta 3, del and delta 3. I will go to that. So this is the delta value. 14, 10 minus 3, 10, 14, 2 minus 3, 2, 6.375. Right. Now we need to find the determinant. 14 into 6.375 minus 2 into 2 minus 10 into 6.35 minus 2 into minus 3. Then minus 3, 10 into 2 minus 14 into minus 3, right? So this determinant value is written. So after simplification we got 310, the delta value is 310, right? So now we'll go to the delta 3 because we need only I3 value, delta 3. So this third column is replaced by voltage matrix 10 0 0, right? The third column if we replace with voltage matrix it will give delta 3. Now we need to find the determinant value. 14 into 0 minus 0 into 2, then minus 10 into 10 into 0, 0 into minus 3, then plus 10 into 2 minus 14 into minus 3, right? So many zeros are there, we can easily identify. So this delta 3 value is 620. After simplification we got 620. So that I3 equal to delta 3 by delta, 620 divided by 310, it is 2 amperes, right? The I3 value is 2 amperes. Now we need to verify with the reciprocity theorem. That is, now we need to transfer voltage source available in the first loop into third loop, and current in the third loop, this is the current in the third loop, will be reflected in first loop. That same 2 ampere is reflected in first loop, we need to verify. So we'll go to the step 2. So in the step 2, transfer the battery to the branch with 1.37 ohm resistor. The following circuit is obtained, right? The voltage source is transferred to third loop. The current through 1 ohm resistor is taken as I3. According to reciprocity theorem, the I3 must be 2 ampere. Let us calculate the value of I3, right? Now we are transfer the voltage source. Voltage source is now transferred. The voltage source available in the first loop is now transferred to the third loop according to the previous diagram. The current in this third loop should be reflected in the first loop according to previous diagram. After this modification we treated this is the loop 1, this is loop 2, this is loop 3. So the I3 should be 2 ampere because voltage source available is transferred to this loop. So the current available in the loop is reflected in this loop I3. So we need to verify I3 equal to 2 ampere. What we got in previous step, the I3 is 2 ampere. So here also the I3 should be 2 ampere. I3 is 2 ampere. Here also we need to get I3 equal to 2 ampere. Then it is the reciprocity theorem is verified. Now we will repeat the same process with the voltage with the matrix method. V equal to I into R. Voltage matrix, current matrix and resistance matrix, right? So this resistance matrix, this is the loop 1 now. Now it is loop 1. Previous diagram, this is loop 1, loop 2, loop 3. Now this is loop 1, loop 2, loop 3. The loops are interchanged, modified now. So the loop 1, the total resistor is 1.375 plus 2 plus 3. So the resistor available in the loop 1 is R11. Then R12, between 1 and 2, this 2 ohm is available. See the current direction. This is going down, this is going up. So minus 3. R13, resistor available between first loop and third loop, that is 3 ohm. This is current down, this is current up. So minus 3. Then this is R21, very similar to this. Then R22, the total resistor available in the second loop, 2 plus 10. Right? Then this R23, second loop and third loop, this 10 ohm is available. So current is also here, is going in a opposite direction. So minus 10. So otherwise, all the current directions are here, same direction we marked. So that other than diagonal, all elements are negative. In previous step, we marked the current direction in different current direction. But here all are uniform. All are flowing in a clockwise direction. In that case, if the all current directions are equal, other than diagonal, all other elements we can put negative. Right? Okay. Then we'll go to this R31. The common resistor between third loop and first loop. This is third loop, this is first loop, 3 ohm. Then R32. Common resistor between third loop and second loop. This 10 ohm. Then R33. The total resistor available in the third loop. 10 plus 3 plus 1. So 10 plus 3 plus 1. Right? So this is R11. Total resistor available in loop 1. R22 total resistor available in loop 2. R33 total resistor available in loop 3. All are positive. All others are negative because of same current direction. This is R12. Common resistor available between loop 1 and loop 2. Loop 1 and loop 2 is 2 ohm. Similarly, this is R13, R21, R23, R31, R32. Then the current is I1, I2, I3. Right? In the loop 1, 10 voltage is available, 10 voltage source. In loop 2 and loop 3, there is no voltage source, so it is 0. So after adding, we got 6.375 minus 2, minus 3, minus 2, 14, minus 10, minus 3, minus 10 and 14. Right? So this I1, I2, I3, 10, 0, 0. So this is voltage matrix, current matrix and resistance matrix. Now we need to find the I3 value. I3 is very similar to previous case, delta 3 by delta. So first we will find a delta. Replacing the third column with voltage matrix will give delta 3. From this we can find the I3. That should be 2 ampere. Right. So this delta value is available here, 6.375. So how to find that? 6.375, 14 into 14 minus 10 into minus 10 is written. Then minus 2, minus of minus 2. For the second case we are taking minus of minus 2. Then minus 2 into 14 minus 10 into minus 3. That is available here. Then minus 3. If we take minus 3, you have to multiply these two elements. Minus 2 into minus 10. Minus of 14 into minus 3. Right? It is all values are multiplied. I think we are able to understand the determinant. Determinant is easy. So after simplification, these are step by step, it is simplified. We got 310 value. So it is very similar to previous case also. Delta value is 310. But now we will replace the third column with the voltage matrix. So that we will get delta 3. So the third column is now replaced with voltage matrix 10, 0, 0. Right. Now we will take this 10 because these two elements are 0. We will take 10 alone. Right. In previous case we proceeded a normal procedure. Now we will take 10. If you take 10, you have to multiply these two. Minus 2 into minus 10. Minus of 14 into minus 3. These two elements are 0. So totally we will get 0 only. Right. So 10 into these two elements are multiplied minus these two elements are multiplied. After simplification we got 620. Delta 2 equal to 620. So from these two value we can find I3. I3 equal to delta 3 by delta. 620 divided by 310, 2 ampere. So the same value we got here also. When the voltage source is transferred from first loop to third loop, the current in the third loop reflected in the first loop, that is I3, is 2 ampere. So we calculated the I3 value and we verified the reciprocity theorem. In both the cases we got same value. While transferring the voltage source, the current is reflected in the third branch, that is 2 ampere. So hence reciprocity theorem is verified. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the solved problem based on the reciprocity theorem contain the DC circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the problem. Verify reciprocity theorem in the circuit shown below and also calculate the transfer resistance. So the circuit is given, right? So the reciprocity theorem is nothing but, we see that the voltage, the current source is available in the branch 1. We'll see that this is the branch 1. We are going to find the voltage in the second branch. Voltage current source available in branch 1. We are find the voltage in the second branch. According to reciprocity theorem, the current source in branch 1 is transferred to second branch. While transferring, the voltage in the second branch will reflected in the first branch. So that is the reciprocity theorem, right? Branch 1 contain current source. Branch 2 we are finding voltage. After interchange, current source available in the second branch, so that voltage should be reflected in first branch. So that V divided by I is nothing but transfer resistance, that is 10 ampere. I is 10 ampere. We need to find the V value, voltage value. So V divided by I will give transfer resistance, right? So in the first step we will proceed the circuit as it is. We will find the V value. Then we will transfer the current source to second branch and find the V in the first branch. So that V divided by I will give the transfer impedance, right? So first we'll proceed with the as it is, the diagram what is given as it is will proceed. Branch 1 contain current source, branch 2 will find the voltage across the 8 ohm resistor, right? So that is the step 1. So voltage across the 8 ohm V equal to I into R, current flowing through the 8 ohm resistor into resistor value. What is the current flowing through the 8 ohm resistor I8? We need to find R value is, we know R value is 8 ohm, but we need to find the I value. What is the I value? I value is, so in this diagram the 10 ampere is flowing through the 3 ohm resistor. At this point the current is diverted using current division rule. We can find the value. Current is divided through this 2 ohm and 8 ohm resistor. So at this point current is divided. So by using current division rule, we can find the current flowing through 8 ohm resistor. What is the formula? I8 equal to total current. This is the total current multiplied by the resistor of the other branch. What we need? We need a current flow through the 8 ohm resistor. So it should be multiplied by resistance of other branch 2 ohm divided by total resistance 2 ohm and 8 ohm. Current is divided in 2 ohm and 8 ohm. So the total resistor is 2 plus 8. Right? So current flowing through 8 ohm resistor is total current multiplied by the resistor of the other branch divided by total resistance. Right? So 10 into 2 divided by 10 equal to 2 ampere. Now we calculated the current flowing through 8 ohm resistor. So that V equal to I8 into R, that is 2 ampere into 8. So 16 voltage. The voltage is 16 voltage. Right? The current is 10 ampere in branch 1. The voltage drop in the second loop is 16 voltage. Now we'll go for interchange. We need to verify the same 16 voltage is reflected in the branch 1 while 10 ampere is transferred to branch 2. So one question we identified, V value is 16. Now we'll find the transfer impedance by interchange. So in the step 2, interchange the current source and response, the circuit given below. Here the response is V, right? So the current source available in this branch is transferred to the second branch. So that the voltage what we calculated 16 should be appear in the first branch, that is indicated by AB. We need to find this V value, right? What is V2? V2 equal to, that is the voltage across this 2 ohm. This voltage across 2 ohm is appear across this voltage across AB, right? Because of parallel. That is I2 into R. R value is 2 ohm. Because of open circuit, current will not flow through 3 ohm. Since the current through the 3 ohm is 0, right? So here also we can find the current divider rule. So at this point the current is divided through 8 ohm and 2 ohm. Here current will not be there because of open circuit, right? So the voltage across AB is nothing but voltage across 2 ohm resistor. Voltage across 2 ohm resistor is current flowing through the 2 ohm resistor into R. R value is 2 because current will not flow through 3 ohm resistor, right? Then how will you find this I2 value? Again we are using the current divider rule. I2 equal to total current multiplied by other branch resistor. So we need current through 8 ohm. So it should be multiplied 2 ohm. We need to multiply by 8 ohm divided by total resistance 2 plus 8, 8 plus 2, right? So what we did is similar thing. 10 ohm total current multiplied by the resistor of the other branch divided by total resistance, that is equal to 10 into 8 divided by 10, 8 ampere. 8 ampere is flowing through the 2 ohm resistor. So that voltage across V2 equal to I2 into R. I2 value is 8 what we calculated into 2, 16 voltage, right? So the V2 is 16 voltage. So same value what we got in the step 1, here also in step 2 we got the same value, V2 equal to 16 voltage. So while transferring the current source from branch 1 to branch 2, the voltage in the branch 1 now reflected in branch 2 will reflected in branch 1, that is the 16 voltage what we got at 16 voltage. So now we verified the reciprocity theorem and also we calculated the V2 value. Now we need to find the transfer impedance value. So in both the cases the ratio of voltage to current is same. Current is 10 ampere, voltage is 16 voltage. Hence the reciprocity theorem is verified. So the transfer impedance, transfer resistance is V divided by R. V is 16 voltage, what we calculated in step 1 and step 2. The current source is 10 ampere. So 16 by 10 equal to 1.6 ohm. So the transfer resistance will be 1.6 ohm. So in this problem, we verified the reciprocity theorem and also we calculated the transfer impedance. That is, current source in the branch 1 is changed to branch 2. The voltage in the branch 2 will be reflected in branch 1. That voltage is nothing but 16 voltage. From this we calculated the transfer impedance. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the solved problem based on the reciprocity theorem contained the AC circuit. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. In the network shown below, the voltage source 100 voltage with angle 45 degree causes current Ix in the 5 ohm branch. Find the Ix value and verify the reciprocity theorem. So the network is given. There are 3 loops available. 3 branches, 3 loops are available. I1, I2, I3. Current in the 3 loops. In the loop 1, voltage source is available. In loop 3, 5 ohm is available. Through the 5 ohm, the current flowing is Ix. We need to find the value of Ix. And also we need to verify reciprocity theorem. The reciprocity theorem is nothing but the voltage source available in branch 1, current we are calculating in branch 3. Based on reciprocity theorem, the voltage source in branch 1 should be transferred to branch 3 so that current in the branch 3 will reflect in branch 1. So that is the reciprocity theorem. So first we will consider the circuit given as it is. We will find the Ix value. In step 2, we will transfer the voltage source to third branch and we will find the current in the first branch that should be equal to this Ix. The current should be equal. So we will go to the step 1. As it is, we will proceed and we will find the value of Ix. We will follow the matrix method, Kirchhoff's voltage law. This loop method using matrix. V equal to I into R. This is voltage matrix, current matrix and resistance matrix. We have 3 loops are available. Loop 1, loop 2, loop 3. I1 is the current in loop 1, I2 is the current in loop 2, I3 is the current in loop 3. This I3 is nothing but Ix. The current I3, the same thing is flowing through 5 ohm resistor, that is also Ix. What we need to find is Ix, that is nothing but I3. First we will frame the voltage matrix. So this is nothing but R11. R11 means resistance, that is impedance available in loop 1, that is 10 plus J5. Then R12, the impedance available between loop 1 and 2, that is this J5. J5 is available between 1 and 2 minus J5. Then R13, resistor available between loop 1 and loop 3. There is no contact between loop 1 and 3, that is 0. Then R21, the impedance available between second loop and first loop, that is J5 minus J5. Right? Other than diagonal, all elements are minus. Then this R22, the impedance available in the second loop, this 10 ohm minus J5 ohm plus J5 ohm. Then this is R23, the impedance available between second loop and third loop, that is minus J5. So already one minus we need to put, is here also one minus is there, so that it become plus J5. Then R31, between third loop and first loop, between third loop and first loop it is 0. Then R32, third loop and second loop, R32, third loop and second loop, minus J5. Already here one minus will be there, so it become plus J5. R33, the impedance available in the third loop, that is minus J5 and 5 ohm. So 5 minus J5. So we framed the impedance matrix. R11 is total resistance available in the the branch 1. R22 means the total impedance available in second loop. R33 the total impedance available in loop 3. This is R12, 13, 21, 23, 31, 32. That is common resistance between first loop and second loop, first loop and third loop, like that. Other than diagonal, all are negative. Then current is I1, I2, I3. The voltage is 100 voltage 45 degree in loop 1. In loop 2 and loop 3 the voltage source is not available, 0. Then after simplification we got 10 plus J5 minus J5, 0 minus J5, this become, these both are cancelled, J plus J5 and minus J5 cancel, 10, then J5, 0, J5, 5 minus J5. So this is the resistance matrix. So our aim is to find Ix, that is I3. So we need to find del value and delta 3. I3 equal to delta 3 by delta. So this is nothing but delta. This matrix is nothing but delta. By replacing the third column with the voltage matrix, we will give delta 3. So first we will find delta. We will replace third column with voltage matrix. Then we will find delta 3. From that we can find I3. Now we will go to the calculation for delta value. So this is the delta value. We need to find the determinant. 10 plus J5 multiplied by 10 into 5 minus J5 minus J5 into J5. So this is given. Already here minus is there. So minus of minus J5, you have to multiply these two. Minus J5 into 5 minus J5 minus J5 into 0. This third element is 0, so no need to worry about that, become 0. Now we will go for further simplification. 10 plus J5. This 10 is multiplied inside. So 50 minus J50. Here minus J5, J5. So the J square 25. 5 into 5, 25. Then these two minus is there. Here also minus, it become plus. So is multiplied inside. Minus J5 into 5. So minus J25. Minus J5 into minus J5. So it is plus J square 25. We know that J square value is minus 1. We will substitute that. 10 plus J5 into 50 minus J50 minus of this J square is minus 1 into 25 plus J5 minus J25 plus this J square is minus 1, 25. Now we can go for further simplification. 10 plus J5, 50. So this here also one J50 plus 25. Minus available 2 times, so it is plus 25. Plus J5 minus J25. This is become negative now. Minus 25. Now we will go for further simplification. 10 plus J5 into 75. 50 plus 25, 75 minus J50 plus J5 into minus J25 minus 25. Right, we will go for further simplification. Now we will multiply inside this. 10 plus J5 is multiplied inside. So that's 750. First multiply with 10. 750 minus J500. Then multiply with J5 plus J375 minus J square 250. 5 into 50, 250. Minus these are these the J5 also multiplied inside. Minus J square 125 minus J125. Right. So the further it is simplified. 750 minus J500 plus J375 plus 250 plus 125 minus J125. Now we will add all the real terms. 750, 250 and 125. 1200 and 1125. Minus J500 plus J375 minus J125. You have to add all these imaginary terms, that is minus 250. So now we will calculate the delta value is 100 and 125 minus J250. Now we will go to the delta 3 value because we need I3. So it is enough to find delta 3. Delta 1, delta 2 not needed. Right. So this third column is replaced by the voltage matrix. Right. So these two values are 0, not J5. It is 0. This is also 0. This is also 0. So that will go like this. 100 into 100 with angle 45 will take this. So that will multiply these two and these two. Minus J5 into J5 minus of 10 into 0. So that also become 0. Right? No need to go here normal procedure, because these two values are 0. We will take this element and will multiply these two elements. Right? So 100 angle 45, this is minus j5 into plus j5. Right? Multiplying these two. So minus j square 25. J square is minus 1. So it totally it become plus. Right? 25. So 25 into 1000, 2500 with an angle 45 degree. So the delta 3 value is 2500 with an angle of 45 degree. Right? Now we'll find the I3 value. So I3 equal to delta 3 divided by delta. Delta 3 is 2500 with an angle 45 degree. Del value is 1125 minus J250. For the division, we need to divide this. Further, the rectangular form is needed. If it is rectangular form, we can divide. So this is available in polar form. Polar form is needed. This is already in polar form. Polar form means magnitude and angle. But this is available in rectangular form. It should be converted into polar form. That is magnitude and angle. How to find the magnitude? Square root of 1125 square plus minus 250 square. Right? We have to square this value and square this value. We have to add and take the square root. That will give the magnitude. That is 1152.44. How to find the angle? Tan inverse b by a. Imaginary term divided by real term. So tan inverse minus 250 divided by 1125. That is minus 12.53 degree. Now both are in polar form. Division means we have to divide this. 2500 divided by 1152.44. That is 2.169 ampere. Right? The angle is we have to subtract 45 minus of 125.3. Sorry, 12.53. So while taking 45 minus it become plus. So that 57.33. So the Ix value, I3 is nothing but Ix. Both are same. 2.169 with an angle 57.53. Right? So division means these two magnitudes are divided. These two angles are subtracted. Multiplication means the angle should be added. So 45 minus of minus 125. So it become plus. So 45 plus 12.53. So that it is 57.33. Now we calculated the Ix value. That is one of the question. Now we need to verify with the reciprocity theorem. Right? Now we'll go to the step 2. So in the step 2, now connect the voltage source in the branch in which the current Ix, that is 5 ohm branch, and connect an ammeter in the branch where the voltage source were connected. Right? So we are now interchange the voltage source from first branch to third branch, and we will verify the current in the third branch will reflect in first branch. So that is the second step. Now see here, the voltage source available is now transferred to the third branch. Now we need to verify current in the 5 ohm is what we calculated Ix should be available in the first branch, I1. The I1 should be the value we calculated should be I1, that is 2.167. Right. So voltage source from branch 1 is transferred to branch 3. Current what we calculated now should be reflected in first branch, that is I1. Now we'll frame the matrix. So it is very similar to what we calculated earlier. 10 plus J5, all the networks are same. This is branch 1, loop 1, loop 2, loop 3. Right? All the values are same. 10 plus J5, R11, minus J5, 0, minus J5, 10 plus J5 minus J5, J5, 0, J5, 5 minus J5. Right? Then I1, I2, I3. Only the voltage is different. In the first loop, voltage is 0. Second loop also voltage is 0. Third loop, we have 100 voltage with 45 degree. Right? So this is R11. R11 means the total resistor in the loop 1. R12, the total resistor in the second loop. J5 plus J5 minus J5. This is R33, the total resistor in the third loop. Minus J5 plus 5. 5 minus J5. This is R12, resistor available between 1 and 2. This is R13, resistor available between 1 and 3. There is no connection, so that it is 0. What we calculated similar. Only the voltage is voltage matrix, the voltage available in the third loop. Right. So this is the simplified form. in this we need to find the again current value. If the current through AB is same as the value of Ix in step 1, we can say that reciprocity theorem is verified. Now we will calculate the current. Now we need to calculate I1 current. Earlier we calculated I3, now we need to calculate I1. Now we will go to the calculation for I1 current. So to find the I1 current, first we will find the delta value. So it is very similar to what we calculated earlier, right? That is 1125 minus J250, that is 1152.44 with an angle minus 12.53. In step 1 we calculated delta, the same thing is here. So the delta value is same as step 1. I will find the delta 1 because we need I1. In step 1 we calculated delta 3 because we need I3. Now we need I1, so we will calculate delta 3. So replace the first column with the voltage matrix, right? So here also change is there. In step 1 voltage is available here. These two elements are 0. Now there is no voltage source in first and second loop, only third loop. So that 0, 0, 100 with an angle of 45. Now we will take this 100 angle of 45, so that we have to multiply these two values. J5 minus J5 into J5 minus of 0 into 10. Right? If you take this value, you have to leave these two columns. You have to multiply these two values. Right? So that 100 angle 45, this is nothing but minus J square 25. J square is minus 1, that is 25. So 100 into 25, 2500 with an angle of 45. So this del 1 value also very similar to the previous case, what we calculated del 3. Right? 2500 with an angle of 45. Now we will find the I1 current. That should be equal to the current what we calculated in step 1. So delta 1 divided by delta 2500 with an angle 45 degree. Delta is 1152.44 with an angle of minus 12.53. See, both are available in polar form, magnitude and angle. So we can divide this value 2500 divided by 1152.44. That is nothing but 2.169. The angle we have to subtract. Division means we have to subtract 45 minus of minus 12.53. So it becomes 45 plus 12.53. That is 57.53 ampere. So the I1 value is 2.169 magnitude with an angle 57.53. So this is very similar to I3 or Ix. So that I1 in the step 2 is equal to IAB, that is equal to Ix. Right? The current what we calculated in step 1 is same as what we calculated in step 2 also. So that reciprocity theorem is verified. While interchanging the voltage source from branch 1 to branch 3, the current in the branch 3 is reflected in branch 1, this I1 value. So that hence the reciprocity theorem is verified. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.